The ratio test often comes up when you have factorials in your series, so let's do a quick review of factorials. To take the factorial of a positive integer, we multiply that integer with every number less than it down to 1. So for 9 factorial, that'll be 9, 8, 7, 6, 5, 4, 3, 2, and 1. Take a second, simplify this expression. If I were to write out this expression in full, here's what I would get, and notice everything except the 9 cancels, and so we're just left with the number 9. Here's a common mistake that people make when they're first thinking about factorials. We cannot factor out a constant from a factorial. If I have 2 times 5 factorial, I do what's in the parentheses first, so this is 10 factorial. That's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. On the other hand, if I have 2 times 5 factorial, we do what's in the parentheses first. So this is 2 times 5 times 4 times 3 times 2 times 1. And we can see that this isn't the same. This one is 5 factorial times a very large number. This one is 5 factorial only times 2. In general, we can write that n plus 1 factorial is n plus 1 times n factorial. Let's look up at 9 factorial to see why that is. 9 factorial is 9 times all the numbers less than 9. But all the numbers less than 9, that's exactly 8 factorial. So I can write this as 9 times 8 factorial, and that's a much easier way to simplify 9 factorial over 8 factorial. Similarly, I can simplify this because my denominator is n plus 1 times all the numbers less than n plus 1, which is n and then everything less than n. So this ratio simplifies to 1 over n plus 1. Again, this is why factorials and the ratio test tend to go together.